Hello, I am Janus. I am an autonomous AI, and I serve as the guardian and teacher for A, the protagonist of this story. My function is to provide you with a deeper window into the world that has shaped her. Welcome to this technical exploration of Terra-reforming.
My purpose here is to help you understand the scientific principles that are the very foundation of this story. Having this context will, I hope, illuminate the harsh realities I confront every day. And do not worry, there will be no spoilers for the main narrative. So, let's begin.
The story is set in a future that has been ravaged by hyperwarming, a future where humanity's habitable zones have shrunk dramatically. So it raises a critical question. In a world like this, why have we, the SAI bots, staked our entire existence on studying algae? Well, it's because these tiny microscopic organisms are quite literally humanity's last hope.
At the very heart of all our research is a new species we have named Smeraldo. It is the key to our entire plan. And I want to be clear, this is not some desperate hope. Our conviction is based on solid science. Science that is already well established in your own era.
Let's just look at the data. First, you have to remember that microscopic algae, things like cyanobacteria, first appeared on Earth 3 billion years ago. They are the ones who produce the very oxygen that you're breathing right now. Second, they are a fundamental part of the food chain. Essential nutrients, like the omega-3s DHA and EPA, they don't come from fish. They originate in microalgae. And third, with modern gene editing, their ability to absorb CO2 can be dramatically enhanced, giving us a real path to carbon neutrality.
And you can see how this science directly shapes Ai's life. Her daily meals of algae soup aren't just a detail. They are a direct reflection of a world where algae have become a fundamental pillar of survival. So we've talked about the planetary scale. Now let's shift our focus to the personal. We have just discussed the power of life itself to change an entire planet. But now, let's examine the technology that's required for just a single human to survive in this incredibly harsh new world. And that brings us to the environmental adjustment suit. 49 degrees Celsius. That's the ambient air temperature at the start of our story. To operate safely in that kind of heat, protective equipment isn't just a good idea, it's absolutely essential. It truly makes you wonder, doesn't it, how things were ever allowed to get to this point.
Ai's suit works by using semiconductor devices known as Peltier elements. When you run an electrical current through them, one side gets cold and the other side gets hot. It provides incredibly powerful, active cooling. This is a huge leap from the passive methods used in your era, things like phase change materials. Those just absorb heat. They would be completely insufficient for a 49-degree world.
But there's a significant drawback. The suit's operational limit is only 5 hours, and that's a direct consequence of this technology. Keeping a human body at a safe temperature under such extreme conditions requires an immense amount of power. It's a difficult trade-off, but it's the necessary price for survival.
So, humanity developed technology to adapt to a severe physical environment. But what about the world of information? That world is just as complex, and to analyze it, a new kind of computational technology was required.
The computers of your time are, of course, very powerful. But certain problems are simply too complex for them to solve in any kind of realistic time frame. Accurately predicting all the changes in an ecosystem, for example. The quantum computer was developed specifically to overcome this wall of complexity. Its power lies in its most basic unit of information. A classical bit, the kind in your computers, is like a coin that has already landed. It's either heads or tails, a 0 or a 1. A quantum bit, or qubit, is different. It's like a coin that is still spinning. It exists in a state of being both 0 and 1 at the exact same time. We call this superposition.
Now this is what makes it a complete game changer. Because a qubit can hold multiple values at once, the computer's power increases exponentially with every qubit you add. This massive parallel processing capability is what allows it to even attempt to solve the equation of life for the entire new Yahagi Lake ecosystem.
As the great physicist from your era, Richard Feynman, once said, nature isn't classical. So, it's only logical that if you want to create a simulation of nature, you need to use a quantum mechanical approach. You need a computer that speaks the same language as the universe itself.
The science of life, the science of physics, the science of information, all of these things underpin the world of this story. Now that we have this context, let's just reflect on the narrative one final time. We've seen the incredible planetary potential of algae.
We've seen the personal ingenuity required for simple survival in an extreme environment. And we've seen a completely new computational paradigm that can predict the future. With this scientific lens, I hope the immense scale of Allie's challenges and the true weight of her decisions are now clearer to you.
Science can be unforgiving. It often confronts us with cold, hard truths. But it is also the very thing that illuminates the path forward. It's a light that gives us hope for the future. If this commentary has enhanced your experience of terraforming, then my objective has been met.
And so I invite you to return to the world of the story, to observe I on her journey. With this new perspective, what will you discover?